Intercepts with the axes. A parabola, or any curve, can make intercepts with the x-axis and the y-axis. The y-axis has an x-coordinate of 0, so we substitute x equals 0 in the equation of a curve to find its y-intercept. For the parabola f of x equals x squared minus 1, the y-intercept can be found as y equals x squared minus 1. The y-intercept is 0, negative 1. The x-axis has a y-coordinate of 0, so we substitute y equals 0 in the function and solve for x to find its x-intercepts. For the given parabola f of x equals x squared minus 1, the x-intercepts can be found as y equals x squared minus 1, x equals plus or minus 1. If we consider the parabola y equals x squared plus 1, the y-intercept can be determined as the y-intercept is 0, 1. To find the x-intercepts, we set y equals 0. There is no real solution to this equation since the square of a real number cannot be negative. A parabola of the form y equals ax squared plus q may not have x-intercepts, but will always have one y-intercept. Let us now determine the intercepts with the axes for a parabola with all the three parameters a, p, and q. That is, a parabola of the form y equals a times x plus p the whole square plus q. The y-intercept can be determined by substituting x equals 0 in the function. Therefore, y equals a p squared plus q. Similarly, the x-intercepts can be determined by substituting y equals 0 in the function. Solving for x, we get x equals plus or minus square root of negative q over a minus p. From the expressions, it is obvious that an x-intercept can only exist when negative q over a within the square root is positive. This is because the square root of a negative number is not real. In other words, the sign of q and a must be opposite in order that the expression q over a is negative, and the expression negative q over a is therefore positive. Determine the x and y-intercepts of the function y equals 3 times x minus 2 the whole square plus 5. For the y-intercept, we substitute x equals 0 in the above equation. Therefore, the y-intercept is 0, 17. To determine the x-intercepts, we first check whether q and a have opposite signs. Since they have the same signs, x-intercepts don't exist. We can also verify this by substituting y equals 0 in the function. As the square of a real number cannot be negative, there are no real solutions, and hence there are no x-intercepts.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.